Welcome back to my channel. So I'm going to create a new playlist on algorithm design part 2, so which will be the important topics that are I'm going to cover in the upcoming semester. So in this video I'm going to explain the three topics. Like I'm going to explain an example like which includes these three topics. Those are sum of subsets, state space tree, and the bounding function. So how we can do the sum based on this concept. Okay, so don't waste the time, let me go to the problem. So here a subset will be given. Okay, so let me take the subset as w equal to set of 5, 10, 12, 13, 15 and 18. Okay, so a subset is given. So with this subset, so how the questions will be asked, like there will be given a sum as well. So given m is equal to 30, this is the sum. Okay, m equal to 30 and w equal to set of 5, 10, 12, 13, 15 and 18. So this is the question. Okay, so we are going to discuss in the example. So three topics will be covered based on this example. So how the question will be asked, like solve the following problem and draw portion of state space tree. We have to draw the state space tree from like tree where m equal to 30. The sum of subset will be 30 and the subset like contains 5, 10, 12, 13, 15 and 18 are the elements in that subset. Okay, now what we have to do? So first, in the given example, we need to understand the question first, right? So what is meant by subset and what is being asked in that question. Okay, so let me take one daily life example. So what is the problem? The problem is subset with sum with backtracing. Though this will sound heavy, but imagine the simple situation. Like you go shopping with your 30 rupees in the wallet. There are 6 items, 5, 10, 12, 13, 15, 18. These are the items that are available in that shop. So what is your task here? You have to find which combination of items you can buy so that the total is exactly 30 rupees. So we will do choice at each step. Like when you stand in front of an item, say rupees 10, like say rupees 5, you have two choices. Either you can include, pick it, or you can skip it, like exclude it. Okay, so you can repeat this until your money spent, that is 30 rupees, like you found a perfect shopping list, or your money spent greater than rupees 30. Okay, like that means you overspent. Then you have to do the backtrack. Okay, now you have checked all the items and you can stop. So in this way you will draw the state space tree. Okay, so for this we will be using the bounding function. So what is bounding function? Like before telling this, I want to start the state space tree. Okay, so let's take x. How many elements? 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, here either I can include this one 0 or exclude this one, like include 1 or exclude 0, like this I will be using. So what is the sum here? 5 plus 10, 15 plus 10, 25 plus 2, 27 plus 30, 40, 55, 5, 10, 65, 65, 8, 73. So total is I am the sum, initial sum I am taking as 0, and I am doing the addition of all the elements. The addition of all the elements is 73. So first step is taking this one. This is the initial step. Okay, so you have to take the first step, sum at 0 and the total sum as 73. Okay, done. Now what I told, either I can include it or exclude it. Okay, either I can include it or exclude it. First I am trying including it. Okay, x1 equal to 1. That means here I am including 0 plus 5, 5, and 73 minus 5 is 68. So in total, if I am adding one thing, that means I have to remove in the total as well, right? Similarly, I am adding x2 equal to 1. That is nothing but 10, 15 and 58. Now here how long we can do, I will be explaining that. See, I am adding this again, x3 equal to 1. This will be 15 plus 12, 27 and 46, right? And again x4 equal to 1. This will be 40 and 33, right? So here, if you can observe here bounding function comes into picture. Okay, what does the bounding function tell? See, the sum of the weights included so far that we are adding, right? should be less than the total sum. That means we are excluding it. Okay, so what is the bounding function comes here in the picture? Let me write here bounding function sum of weights wi we are doing, right? Sum of the weights that included so far I equal to 1 to k. Okay, and w of k plus 1 should be less than or equal to m of the weight of the next object. So sum of the weights included so far that we are adding, and weight of the next object should be less than or equal to m. So here this side the adding, we are adding, right? See 5, 15, 27, 40, all these we are adding, right? This should be always less than this, should not be greater than this, or we can say like this as well. So I am stopping at this step. So till this time x1 included, x2 included, x3 included, x4 included. So we are not excluding now x4, we are not including x4 now. So x4 equal to will be 0. Then it will be 27 will be, we are not adding anything, but in total it will be mixing like this. Okay, now I am adding x5. If I am adding x5, 27 plus x5 is 15, right? 1, 2, 3, 4, 5, 6. If I add 15, 27 plus 15, 43, and I remove it, 18. So it is greater than again, right? x5 equal to 1. Again I am removing this, and I am removing x5 here. So if I remove, the sum will be same. If I remove that 27, and it will be 18. So here what it will happen? Yeah, now it is okay. So you can see it, right? You can see here sum of up to 5 elements, like including 1, 2, 3 and excluding 4, 5, we got 27 and 18. Okay, after removing this. So last element, if we add last element x6 equal to 0, or what we will get 45 comma 0, which is not satisfying the bounding function. And if we remove it, like x6 equal to 0, it will be 27 and 0. So 27 is not equal to 30, right? So this is also not satisfying. So with this, another bounding function came into picture, 27, right? So bounding function, what we can write the bounding function? Sigma wi. That means sum of the weights that are included so far. Okay, I equal to 1 to k plus sigma I equal to k plus 1 to n wi like greater than n. This is nothing but remaining weights that you have. Okay, remaining weights that you have. See what we have done till now. See, we have taken the sum, initial sum as 0 and the total sum as 73. Like we have added all the elements in the subset, I mean set. Okay, after adding that, we are doing including and excluding. First we are including. After 3 including, fourth including is like 40. I got 40. If I add 40 plus the next element, okay, next element is fifth one is 15. 40 plus 15 is 55. So if I add, then it will be greater than m. So which is not which I don't want. So I want the sum as 30, right? So that's why the sum of the weights included so far plus weight of the next element should be less than or equal to m. Okay, sum of the weights included so far plus the weight of the next object should be less than or equal to m. And the second one condition is the sum of the weights included so far, okay, plus the remaining weight you have should be greater than m. Okay, yeah. Okay, now x6 is sixth element, fifth element, fourth element is excluded. Now let me include third element. Okay, if I exclude third element, then what it will happen? 15 will be remain same and it will be 46, right? Yeah. Now what I am doing, I will be including this x4 equal to 1. X4 equal to 1, then what it will come? X4 is nothing but 13. 15 plus 13 is 28 and it will be 33. Okay, so 28 still we can do. So if I do x5 equal to 1, right? So x5 equal to 1, nothing but 15 including 15, I will get 28 plus 15, that is 43 something, and this is 18 excluding that. So which is not satisfying this bounding function. Okay, and next, so I have included x5, right? Now I am excluding it. x5 equal to 1. Okay, x5 equal to 1. So if I do that, 0. If I exclude that, then what I will get? 28 as 28, and after removing this 18. So still I can do. See, here it is less than 30 only, and if we add last element x6 equal to 1, see, definitely it will be greater. 28 plus sixth element is 18, 38, 46, and it will be 0. So it is not satisfying the condition. And if x6 becomes 0, then it will remain as 28, it will be 0. This is also not satisfying, right? 28 comma 0, where it is not equal to m, right? So I'm removing this as well. So 6, 5 and 4 is not removed, right? 6 and 5 is removed, but 4 is not removed, right? So I'm removing 4 here. x4 equal to 0. So I'm not doing in a correct way, but still you can do, okay? Just you have to understand the concept. If you know this concept, right, you can write it on your own, okay? Any set is given, you can write, okay? So x4 equal to 0. After that, I will get 15 and 33. So here, if I remove x5 equal to 1, if I add x5 equal to 1, then it will be 15 plus x5 with 30 and it will be 0. So you can see this, right? x5 equal to 1. When x1 equal to 0, x2 equal to 1, x3 equal to 0, x4 equal to 0, x5 equal to 1, then I am getting the m addition as 30. That means x1 equal to 1, the solutions x1 equal to 1, x2 equal to 1, x3 equal to 0, x4 equal to 0, x5 equal to 1, and similarly x6 will be 0. Okay, so here 1, 2, fifth element, 1, 2 and 5 elements. So subset is 5, 10, 15. If you add this, you will get 30. See, 10, 20, 25, 30. Yeah. So what we have done till now. Okay. So a subset is given and the sum, what should we have to get? That is also given. So what we need to do, we have to draw the state tree and with respect to the bounding function. So I have explained the bounding function, right? Sum of the weights included so far plus weight of the next object should be less than or equal to the sum. And what is second one? This is the first condition. The sum of the included weights that are included so far and the weight of the next object should be less than or equal to m. This is one condition. Another condition is given here. See, you can see this, right? Sum of the included weights so far and plus remaining weights you have. What are the remaining weights you have, right? Should be 27 plus 0 should be greater than m. Okay. So if you add these two, 27 plus 0 should be greater than or equal to m. Okay, so greater than or equal to m, I can say. Okay, done, right? So what you have done, after taking subset, you have taken the initial sum as 0 and after that the maximum sum is 73. So here you can see, again you can take x1 equal to 0, x2 equal to 1, x2 equal to 0, like this you can do multiple steps, but it is the one of the step here, 30, you got it right, the exact value you got it right. So it is the one of the solution. If you take another one, maybe it possible, there will be multiple solutions, but proving one solution is enough for this. So yeah, with this I am concluding the topic, sum of subsets which are writing, right? Subset I am writing, and the state space tree, it is the state space tree. Okay, and bounding function, these are the two bounding functions that I am using. Yeah, these are the three topics that I have covered. So I will be providing one more question based on this same topic. So try to answer that. If you have any doubts, you can comment me in the comment section. So thank you guys for watching my video. If you found my video helpful, so don't forget to subscribe and share it to your friends. Okay, thank you.